In level 3, we will be graphing log functions using transformations such as reflections, stretches, and shrinks, and then we will still have shifts like we did in level 2. So looking at this function, y equals -3 natural log of x plus 2 minus 1, the horizontal transformation that's inside by the x, the plus 2, is going to be shifting 2 units to the left. Shift left 2. The things that are affecting the y values are on the outside, so the -3 and the -1. The -1 is a shift down 1. And that -3 that's being multiplied by the function is a vertical stretch. By a factor of 3, so it's getting 3 times taller, or stretching vertically by a factor of 3, and then the negative in front of that 3 is reflecting this graph vertically, so it's a vertical reflection over the x-axis. So reflect over the x-axis. So we have a lot going on in this graph. Remember that to start with, our graph of natural log of x had a vertical asymptote x equals 0, and we plotted the 2 points. If we made a table for ln of x, the 2 points we plotted were 1, 0, and e1. So something like this. Okay, so this is the graph that we're transforming. Let's start by applying the horizontal shift. That's going to change where my asymptote is. It's shifting 2 to the left. So that's all that's affecting the x values. They're going left 2. So I'm going to draw a vertical asymptote at x equals -2. Now, the y values we have a lot going on with them. They're shifting down 1, and they're being multiplied by -3. So one way to figure out your new y values is to take the y values in the table, multiply them by -3, and then subtract 1. So 0 times -3 minus 1 is -1. 1 times -3 is -3, minus 1 is -4. So, and my new x values, since we shifted left 2, we get 1 minus 2 was -1, and then e minus 2, which is about 0.718. And that would be our table for -3 natural log of x plus 2 minus 1. Okay, so to graph this function, I'm going to start with this point right here. It's not going to be affected by the vertical stretch if I multiply, because when I multiply that 0 y value by -3, it's not going to change. So it's not affected by the reflection or the vertical stretch, but it does shift down 1. So my first point that I draw is right here. It's over 1 from the asymptote, 1 to the right from the asymptote, and shifted down 1. And then my next point would normally go over e up 1, but instead I go from here, from right here, I'm going to go over e, or about 2.7, and down 3, because I'm reflecting and tripling the y value. So it's going to land about right there. And this log function is upside down. It reflected over the x-axis, So it's going to look like that. And the domain is negative, the lowest x value is -2 to infinity. The range is -infinity to infinity. In this next example, we are transforming log of log base 10 of x, so we get log of -x minus 1. So the transformations for this one, since we have a negative in front of the x, that's a horizontal reflection, which is over the y-axis. So we're reflecting over the y-axis, and we're shifting. Since that -1 is on the outside, it's affecting y values, it's a vertical shift down 1. So remember our graph of log of x had a point at 1, 0, and then a point at 10, 1. And it looks like this. It had a vertical asymptote at x equals 0. We have no horizontal shift, so the asymptote is going to stay at x equals 0. Now, since we're reflecting over the y-axis, the graph was over here, but then it's going to flip and be over here. But let's draw it prettier. Okay, so it's reflecting and it's going to be on the other side of the y-axis, and then it also is shifting down 1. So I'm going to start with this point right here. I'm reflecting it over the y-axis and moving it down 1. It lands right here. And then my point that would be over 10 up 1 is reflecting to the other side of the graph and moving down 1, so it's going to be -10, and then the y value moving down 1 is going to be 0. And then we graph it, and it looks like this. So the domain of this graph, now it has lots of negative x values, it doesn't have any positive ones. It's going to go forever to the left, so -infinity would be my lowest x value, because it doesn't have a lowest x value, and then its highest x value approaches 0, but it won't ever hit it, so we do a parentheses. And then the range is still -infinity to infinity for all log graphs.